Typically the way these videos start, there ends up to be a giant box on the bench. In this particular video though, this box did not come from a popular auction site. What is in the box is actually what's printed on the box. In this case we have a Lee & Lee by Dear Bauer, and this is a box with a computer case. So plans for this video is I need to transplant my editing computer from the current case that it's in into this case. Back in March, when everything started blowing up, I had to do some things real quick and I didn't have enough time to research parts as much as I'd like. There are some struggles in the editing computer in the case that it's in currently. The main one is I need room for 2 more 3.5-inch drives so I can set up a RAID 10 array in it. That'll help with the editing and things like that. So this will support the 4 drives I need for RAID 10. The other one only supports 2 drives, can't use RAID 10. So we have to transplant the case, which is going to be tearing the entire computer down, rebuilding it, putting it in this case. Shouldn't be too much of a big deal, but I figured I'd bring you guys along for the ride. We'll talk about some of the components selection that I did when I built this computer. This computer's a monster. It really is. This is a workstation class computer by far. I'll go through the specs when we have the board open, and we'll go from there. So let me get the case out of the box, and I'll show you guys the feature that I absolutely needed this case for. Should look pretty good, given that it's mainly tempered glass and everything like that. Although this sits under the bench, this sits under the editing desk behind the bench. So I'm more interested in the horsepower of the computer and how long it takes to render videos, which is actually not too long for this machine. I built this before I started the YouTube account, and it's done very well in the editing. Nobody sponsored anything in this video. All of these parts were purchased with my money. Nobody donated parts or anything like that. I'm not affiliated with any of the brands that are in here. So if anybody has any comments, questions about the build, feel free to leave them in the comments below. I do read all the comments. But let me get this out of the box and then we'll get into it. Well, here's the computer out of the case. So for front I/O, I've got 2 USB ports down here at the bottom. Those look like USB 2. These look like USB 3. Up here, I got a USB-C. That's a switch of some kind. Power switch is there. Reset. See what that switch is for. That's probably for most likely fan control or something like that. Maybe brightness. I don't know if this thing's RGB or not. So I hope it's not too obnoxiously RGB, since we typically run, when I'm not shooting video, we run with lower light in the lab. So sometimes when things are obnoxiously RGB, they'll light up the room. But here's what we'll do here real quick. The front audio ports I probably will never use, honestly. I'm on USB headsets at this point, so. But this one is also not my gaming computer. I do have a gaming computer, and if people are curious about that one, I'll do a video on that one. I'm not 100% sure how I'll get that in the shot, because that case is gigantic. This is insanely reflective. It'd be nice to get these panels out of the way. Let me get this glass panel off, and then a public service announcement about working with tempered glass. And the glass panel. So the public service announcement on tempered glass is, if you guys are unfamiliar with working with it, don't ever try to cut it. Don't ever try to drill it. The way it's made creates a lot of stresses in the glass that make it very sturdy if you hit it on a flat or anything like that. But it's very weak on the edges. You hit an edge, tempered glass edge, the whole panel will explode. The crack won't stop. It'll just shatter the whole thing. So very strong on the flat surfaces, very weak on the edges. So especially when moving around case panels, things like that, make sure you don't shock the edges of the glass. It's a real easy way to break it. Okay, right here is the whole reason for actually buying this case here in the back. This is one of the few cases that's this size in the mid-tower size that still supports 3.5-inch hard drives. And because I want to do RAID 10, I need 4 of them, so I've got the 4 slots I need. Here's all the... Haven't needed a screwdriver yet. There's all our case hardware. These are the drives for now, so they don't get lost. And let me go get the parts donor. Well, not really parts donor, but the other tower. We'll throw it up on the bench, and I'll kind of go over what the specs are of the computer and what we're going to be building in here. And then we'll start tearing down the other one and pulling parts out and getting them ready to go in here. I've already backed up all the data on the secondary hard drive in the other one. I pushed it up to my file server, so I don't need to worry about that. We can actually blow it away and recreate the RAID. I didn't want to take a chance with any kind of migration or upgrade or anything like that, so I'm just going to wipe out the 2 drives that are in there, reset up the... It's in RAID 1 right now, mirrored, which is giving me the redundancy, but it's not giving me the performance. So RAID 10 will give me the redundancy and the performance. It'll mirror, it'll stripe the 2 sets, and then it'll mirror the 2 sets of drive to each other. So stripe will give me the performance, the mirror will give me the redundancy. So I'll have high-speed drives, but I'll also have redundant drives. It's a nice set of both worlds. It's fast. It is expensive. RAID 10, you need 4 drives of minimum of 4 drives. You can do RAID 5 with 3 and still get some speed increase and redundancy. Not as much of a speed increase as RAID 10. So let me pull this off. I'll get the other unit up, and we'll start talking about some specs. Okay, and here's the donor case. This has got the actual computer in it at the moment. Corsair 500D case. Actually, very nice case. Just didn't have enough slots for me, so I'll have to move to the Leon Lee. We'll get an interesting view. This computer has run daily for probably about 8 months. Haven't cleaned it, haven't done anything, haven't even hit this with an air compressor yet. Literally pulled this out from underneath the bench. So the lab is on a lower level, and we do have a cat. So it'll be interesting to see how the filters held up, how dusty it is on the inside, and everything like that. So let me, I'll flip the side panel off, and we'll take a look on the inside. Actually, let me just pull that off. I'll do it on camera. Okay, will the dust mitigation have done its job, or will this thing be gross? A little bit of the case is coming apart after a bit. Not sure I'm thrilled with that. Might have to call Corsair about that one. So I'm going to move this out of the way. There's some dust. So a little bit of dust in there. All right, and here's the machine. So how to do? Yeah, that's the top of the power supply shroud. About 8 months worth of constant running. This thing doesn't run 24/7, but it runs daily. So could use a bit of a cleaning. Nothing too major. Well, I would say the dust filter is doing its job. So that will get cleaned out for whatever goes in this case next. So in terms of specs, it's kind of a simple computer. We're on a 9980XE from Intel, which is the 18-core, 36-thread. 128 gigs of RAM, which is the most that CPU will support, so fully populated with Corsair Balstix memory. RTX 2070 graphics card. The 2070 was the minimum card that I could get for my particular requirement. This computer has to drive two 40-inch 4K displays. So the 2070 was the minimum card at the time when I built this that was in stock that could drive two 4K displays, regardless of the screen size. 3 120mm Noctua fans, the 3 Corsair maglev fans on a self-contained 360mm AIO. That's in push-pull, so its airflow is going this way. We also have a couple fans up top that are pushing air down, and then this is actually set up as exhaust. Power supply is also set up as exhaust. So we have all those fans pushing air in. That's actually exhaust pushing air. The fan up here is actually exhaust pushing air out. The fan in the back is exhaust pushing air out. I have never had an overheating problem with this computer, even running it flat out. The CPU gets warm, but no overheating. That 360mm AIO is holding up just fine. I'm also not doing any overclocking on this one, because on this one, when I'm rendering videos and things like that, stability is paramount. So no overclocking on this guy. I'm sure that's going to bum some people out, and I'm sure I'm going to catch some flack in the comments from going with an Intel CPU and not running with a Threadripper, but that's what I did. So what I will do is, I was going to try to move the rad without unbolting the CPU, but now that I look at it, I think the easiest thing for me to do is going to be pull the graphics card out, uncork the CPU, yank the power supply, and that's pretty much all we need to do other than transfer the motherboard out to the new case. I will do more cable management in the new case. This was put together at about 12 o'clock at night, and I needed this the next day, so I did not have much time. Once it booted up and posted, that was what I needed. I was also kind of panicking because I had this one and my gaming computer shared some parts, and neither one of them were working, and it was just a bad day in the lab. Ended up being a random one of my FireWire PCI card was preventing the computers from booting. The motherboard didn't like that specific card. I kept the FireWire card for a M-Audio 2626 preamp that I ended up not using because the FireWire card doesn't work. So let me, actually that radiator looks pretty clean. It'll be interesting to see what it looks like with the Noctua fans off the top. So I'll unbolt the heatsink, we'll pull that out, and then I'll start disassembly. Once I get everything disassembled, we'll come back. The other main problem with this particular case, only room for 2 hard drives. You got plenty of room for 2.5-inch. Only room for 2 big ones. These are 4 terabyte, and this is the mirrored array. There's going to be 2 more 4 terabytes that are going in the Lion Lee. And then it's going to be these 2 plus those 2, which is going to make the RAID 10, which will give me the speed I need for editing. And this is my active storage for editing. I have bulk storage back in the computer rack in the back. That is a big RAID 6 array. So everything's good there. When you start working with video, it gets dumb. You chew up drive space like candy. So especially when you start shooting video, things like that, editing video, you can never have enough drive space. It just seems to evaporate. So that's the main reason for the move. My only beef with the new computer cases is I'm one of those weird people that still actually uses a CD drive. Actually, come to think about it, I still use a 3.5-inch drive too. But that's because of some of the older vintage gear that I have. Some of the stuff you actually have to feed it floppy disks that aren't really floppy anymore. The main way the system's set up is C drive for this is a M.2 drive. Which is hiding under this heatsink down here. Which Asus board is this? I honestly don't remember what Asus board that is, but it's an Asus Republic of Gamers board. But anyway, we'll tear it out, and when I get a better shot of the board, I'll bring you guys back. So let me get started on bolting some of this stuff, and then we'll strip this case down. One thing I thought was pretty impressive, the dust mitigation on the case was actually working pretty well. We had a little bit of surface dust, things like that, but the heatsink for the graphics card, there's no dust bunnies in there. I haven't even cleaned it. All I did was kind of brush off the top, just pulled it out. So either those fans never turned, although they have a little bit of dust on them, but there's no dust bunnies or anything in the heatsink, so that actually kept the card pretty clean, especially with that being a pretty warm part. So I'm okay with that. Okay, this actually looks really good. I pulled the pump off for the AIO, and we had good thermal paste coverage. Everything kind of spread out. Like I said, this computer's been running for about 8 months, so that thermal paste is pretty cooked. Obviously, this CPU gets really hot, but everything looks good on that. There's no overflow, especially with this being conductive. You don't want any thermal paste to get down over here, so it should all stay on the thermal spreader. We had good coverage, but not too much application, so that's just about perfect. What I want to see when it comes to thermal paste. Nothing falling over the edges, but we don't have any bare spots. So very good coverage on the CPU. Everything looks good. I'll be cleaning this up with isopropyl alcohol. One thing to know is this is Arctic Silver. If you're using the Arctic Silver or using any of the silver-based thermal compounds, they stain really, really badly. If you get them on the case, if you get them on your clothes, if you get them on any kind of peripherals, that silver color may never come off. So just be careful when you're cleaning them. I got to unplug the rad from the back. This line goes up into the back for the pump power. Once I get the pump loose and get that unplugged, I'll pull out the radiator. Anything else interesting happens, I'll bring you guys back. At the moment, I'm going to get some paper towels and some alcohol and clean this up. This stuff cleans up real easy with isopropyl, so not a big deal. But I'll get that all cleaned up, and then I will be back. Okay, here's the Corsair 360A water block. Cleaned it up. But look how polished that is. So that transfers heat real well out of the CPU, because the CPU gets really hot. And just so nobody can say I'm cheating, i9-9980XE. I'm not going to desocket the CPU. There's no need to desocket the CPU since we're going to transplant the entire motherboard, so for the safety of the socket and the processor, I'm just going to leave them in there. Just going to see if I can buff some of this last thermal paste out, because I'm still pulling Arctic Silver off of this heat spreader. There we go. All right, the next step's going to be pop these two screws out. This front plate's going to come out, and that'll let me access the screws, because this front cover does not come off right here. So I got to pull these out. This will come out, which will let me get the radiator out. So the next thing is we'll pull that AIO out and unhook all the fans and keep going. Okay, before I tear down the rad a little bit, the heatsink's not very dirty. I got a little bit of dust and everything in there, but it's not really choked or anything like that. Maybe hit it with an air compressor before I put it all back together, but not a lot of dust on the fans, not a lot of dust inside the rad. This is probably actually the worst fan here. Everything else looks pretty good. So what I'll do is I'll get the power drill, and I'll just zip out all these screws. I use a small 12-volt DeWalt when I have to undo a whole bunch of stuff. So I'll get that done, pull this apart. But yeah, this is actually really clean considering that it's run almost daily for 8 months without ever being cleaned. So I've never shut this down, I've never pulled it out, never blown the dust out. So this is actually in really good shape. So pretty happy with the dust mitigation in the 500D. So, but I'll get all these screws pulled out, because there's 1, 2, 3, 4, 5, 6. Yeah, 6 screws per side. Don't need to pull the don't need to pull these fans off. I just need to pull these out, because that bracket's got to stay with that case. The way I wired it is all the Noctuas actually come with a Y connector. So all the fans are actually powered by the pump. So the Y connector, it's the way it's set up is it's 2 sets of fans. So with the Y port, the pump controls these two, and these two, because it's got 3 inputs on the pump. So everything worked well there. I am going to tie these up tighter, make them look a little bit better, but without custom length cables, there's only so much you can do. But let me tear that apart, and I'll be back. Well, here's the radiator with the fans removed. It's a little dusty, but it's actually not too bad. This is just light, fluffy dust. Nothing major. This will clean off with an air compressor, no problem. So we'll just blast all that out before we put it all back together. But yeah, for 8 months, this is not bad. I have seen way worse when it comes to working on computers. So now this is completely healthy. Everything looks good on this radiator. We'll be reusing that. Okay, I have the board loose. So I have it sitting in the old case just on the standoff. So I had to get the I/O shield off. So these come with the motherboard, and they're custom cut for the back of the computer. So you have to go on first before you put the motherboard on. Everybody's made the mistake. You put the board in, and then you open up the bottom of the box, and you go, ah, crap. So everybody's made the mistake. Be careful when you pop these in and out. This is really thin sheet steel. This is like a knife. I have been sliced open more times than I can count on these I/O shields. Just be careful when you put everything all together and get it all situated. I'm going to get this popped in the new case, and then we're actually about ready to start putting things into the new case. So I've got all the boards stripped down, the hard drives are out, the video card's out, the motherboard and power supply are still in there. I'm also scavenging a couple of fans out of the old case, so I'll put these in the new case just so I can improve some airflow. But yeah, that's where we're at the moment. So let me get this popped in, and then we'll start working on power supply and motherboard. Okay, we have the board at home in the new case. I did have to change the screws. There's 2 different types of screws typically used in computers. One is a coarse thread. The other is a fine thread. So on the old case, the standoffs needed the coarse thread. On the new case, they needed the fine thread, so I had to switch the screw types. Typically, where you'll find them is the case could be either or, but the smaller screws, these are typically for CD-ROMs and SSDs. These are typically for 3.5-inch hard drives. But of all the computers I've worked on and everything that I've repaired and everything like that, you'll pretty much only find these two sizes of screws unless you're working on a laptop. If you're working on a laptop or some of those microcomputers, all bets are off. But this is primarily the what you'll run into. In this particular case, there's this oddball screw. These are actually for the hard drives. So these bolt the 3.5-inch drives into the socket. That's why there's the non-threaded portion. It holds them into the caddies, but it prevents you from over-tightening it and cracking the board on the hard drive. So everything's going well so far. New motherboard, or existing motherboard, mounted in the case. All the RAM and the CPUs are in there. Everything's good. I need to start unthreading the front panel connectors and all the wiring for the case. Get all that hooked up, all the ancillary stuff. Get the SATA ports hooked up and get the power supply installed. So let me go ahead and pull the power supply out of the old case, and I will do that next. Well, once again, the dust mitigation in the 500D was actually pretty good. 8 months of running, and I have not cleaned the power supply. This is the way it came out of the case. So I got a little bit of surface dust on the top. Other than that, barely any dust on the fan blades. Everything looks good. The power supply for this particular beast is a AX1200i by Corsair. For ultimately no particular reason. I think it was what Micro Center had that day. This is just a 1200 watt. Typically when I build the workstation class or gamer class desktops, I like putting in a really beefy supply unless I'm on a tight budget. That's a customer's preference. The reason I personally use larger power supplies is it doesn't stress the electrolytics on the outputs as much. So it's like taking an engine and running it at 100%, or taking an engine and buying a bigger engine and running it at 50%. If you don't hit it as hard, the power supply will last longer. The electrolytics on the outputs of these, they take an absolute beating because there is some beefy currents in these. If we take a look at the DC outputs, yeah, on the 12-volt rail, the DC output 12-volt rail, there's 100 amps that can be drawn from this power supply. So you can get 100 amps of 12 volts, and it can also put out 30 amps of 5 volts and 30 amps of 3.3 volts. So there is some beefy current that comes out of one of these things. If you're buying a power supply for a computer, make sure you bias the power to the 12-volt rail. A buddy of mine, I've only ran into it once in all the years of building computers, but a buddy of mine, he bought a 1,000-watt power supply, but it had like 30 amps on the 12-volt rail, but it was rated for something like 160 amps on the 5-volt rail. Make sure the power is biased, evenly spread out, or at least in modern-day computers, 12 volts is more important than 5 volts. The computer uses a lot more 12 volts than it does 5 volts. These are 12-volt connectors. These are the CPU power injection ports. These are 12-volt connectors. The graphics cards have 12-volt connectors. Pretty much most of a PC runs on 12 volts. So if you're going to have an unbalanced power supply, make sure it's biased to the 12-volt rail, not the 5-volt rail. You still need a decent amount of 5 volts, but it's far less critical than 12. Also, over-designed power supplies, you can never have too much power unless you're tripping the breaker. Then obviously you have too much power. There is a maximum 1,875 watts, at least in the US where I'm at, is the most you can pull out of a 15 amp residential circuit. Anything more than that, and you will need more than one circuit, which most people don't have more than one circuit to run their computer. So the 1,600 watt power supplies are about the highest you'll see for computers, simply because the electrical outlet cannot push more than that once you get the other peripherals hooked up to it. So you're really pushing. If you're drawing a full 1600 watts out of an electrical outlet, you are really pushing the circuit as far as it can go. If you're on a 15 amp circuit, if you're on a 20 amp circuit, you still got a little bit of headroom, but you're getting up there in terms of current flow through the wires. So that's why you won't find many computer power supplies that aren't server based, bigger than 1200 watts. I have a server in the back. If anybody's curious, it has 4 1100 watt power supplies in it. The thing is a monster. It's 4,400 watts to start the thing. I don't turn that on very much unless I actually need to do some really heavy computing, because I don't like feeding it. It noticeably moves the power bill if I have that running for any length of time. So it's just a monster. So yeah, I'll get the power supply put in. Nowadays, if you're building a modern gaming computer or a workstation-based computer, my personal recommendation, just for my comfort level, at least for me, what I tell my customers is 850 watts or more to give you headroom just in case you want to upgrade. And some graphics cards, depending on what graphics card you put in here, some graphics cards will draw 320 watts by themselves. So you get a high-performance power CPU, you get a high-performance graphics card, a 650 or a 550 watt power supply just ain't going to cut it. So 850 or better, and you'll never have a power supply problem unless it starts to fail. Well, turns out I was slightly mistaken. When I looked at the USB ports on the front, these are the two USB plugs for the front panel connections. They are both USB 3. So turns out the USB ports on the bottom here are USB 3, and the USB ports up here are USB 3. So that's cool. Power supply is mounted. Everything's good. I got to read the manual about that, how to hook up that. That is a given. We have SATA power on that one, and then we have this other connector. Nope, sorry. This is the fun part about building a computer, is hooking up all this stuff. And I'm being sarcastic. Front panel connections are a pain. We have this, which is a RGB header. So we have some RGB in the case. I don't know what that is yet, and I have to figure out exactly how to hook up the RGB header. There is a header on the board, but I need to make sure this is out or in before I just randomly plug it into the board. Here are the two bays for the SATA connectors. They're actually permanently wired with power and data, so that's actually really cool. That means they're a hot swap. So that'll be very nice. Lots of places to hide SSDs in here. This panel actually goes over here. It'll help me do some cable management, but I can park SSDs on here. I can park SSDs on here. There's lots of places to mount stuff. I think those are SSDs. They're sized possibly for SSDs. I'll have to see. These are probably for fans and radiators, because you could put that's solid. That wouldn't be a rad. So that's probably more SSD drive mounting. So looks like you can put lots of hard drives in here, but I have some old 120s that I might throw in here as scratch drives for Premiere. Not sure yet. 4 3.5-inch bays for the hard drives for the RAID 10 array. When I get into those are going to be Western Digital black drives. I'll talk more about that when it comes time for those. But for now, I'm going to work on wiring this stuff up and continuing on, because this build is actually going very well. So I will be back once I get this jungle cleaned up a little bit. Okay, here we are with the board mounted, the power supply's in, and I've made all the front panel connections. I have the 4 SATA ports for the 3.5-inch hard drives, the M.2 drives hiding under here. Haven't popped the graphics card in yet. I'm at the point where I got to go out to the garage and fire up the compressor, because I got to get the AIO cleaned up before I throw it back in here. Yeah, everything's going really well. Front panel audio, there's the 2 USB 3s, there's USB-C, SATA, front panel headers, power, power, power. And that's really all the connections for a motherboard. Next up is getting the AIO mounted or put back in. It's going to go up here. So the radiator is going to go in this space here. I'm going to put some fans down at the bottom here. So the way I'm going to have the airflow in this case is it's going to come up because heat rises, so the convection is going to help it. But it's going to be forced air up, exhaust here, and exhaust here. So I may actually have to flip the fans over on the radiator. I'm not sure yet. So we'll draw cold air in from the bottom, and then exhaust it out the top. So it'll be interesting to see what my temperatures look like after that is all configured. But we're pretty much into the home stretch. The hard parts are done. The board's mounted. The front panel's connected. Most of it. I've done some preliminary cable management in the back with some wire ties. As I said, you can only do so much without custom cut cables, but keeping everything out of the way. I got one more SATA port left. This is for the AIO. So hard drive, RGB controller, AIO will be there. So I won't actually need to use another SATA connection. And then that plate will cover up right here. So we'll tuck this all back in over here. And then that plate will cover up. So it'll look real nice when it's all said and done. But yeah, everything's going good so far. On to cleaning out the rad and then mounting the AIO. I will get that done and then I will bring you guys back. Of course, nothing works according to plan. The heatsink's clean, blew it off with the air compressor, so when I pull these fans off, I'll show you guys what that looks like. It's all nice and cleaned up. But I want the Noctuas on the intake side, not the exhaust side. Plus, the way this is set up now, it's pushing in, so they're intake. So what I got to do is I got to unbolt all these fans, flip them over, but I'm going to move the Corsair fans up to the top, put the Noctuas on the bottom. The Noctuas have a higher static pressure. So I'm going to unbolt a whole bunch of screws, and I'm going to just get the radiator reconfigured. Also work on tying this up, making that look a little better. And then we should be ready to bolt this into the case. Okay, I have the fan nest removed. It's back on the bench. I got to clean that up still, but it's unbolted from the radiator. So we have a cleaner rad. You can see through it. So no dust bunnies there. Everything looks good. Actually, this is a really, really clean radiator. Cleaned up real nice. So that's done. So the way it's going to mount in the case is I want the hoses to come down towards the front like this. So I want to put the Noctua fans blowing this way on the bottom. And I want to put the Corsair fans on the top blowing that way as well. Now, if you haven't built a lot of computers or messed with some of these fans, on some of these, I'll zoom in here real quick. Most PC fans are marked. The marking is blade rotation and airflow. So that's telling me that the fan spins this way and the air is pushing out the top. So that'll tell me how to mount them to the radiator to get the best airflow. So let me cut all these apart and get everything all mounted up to the radiator, and then we'll see if we can't do some better cable management. Okay, well, we have a reassembled radiator. The Noctua fans are going to be on the bottom, so this whole unit's going to actually flip over. This cable bundle is actually going to hide behind it, the radiator, when we actually install it in the case. Everything's wire tied down to the pump, so it's about as neat as we can get it with as much cable as is there. The way I have it set up is these Noctua extensions. Only one of the fans is hooked up to the tachometer for the speed sensor, so I have that set up as the Noctuas are what the computer is going to be monitoring for speed, The maglevs that are on the back, those are just getting power in PWM. Now, these particular fans, they're super, super quiet, so I don't PWM any of these particular fans. I just have them run flat out all the time because they're just so quiet. So that's not even going to be an issue. So we'll get that going, and then so let me get this mounted in the case, and then we'll work on putting the pump back on the processor. Okay, I have the radiator mounted. It's a 360 millimeter rad. Clears my power connectors with the double stack fans by about about an eighth of an inch, but an eighth of an inch is really all we need. So that's actually good there. So the next step is mount the block. Get this mounted back on the processor. But I'll need to go get some thermal paste for that. So I will mount that. I will get that mounted. And then really we're ready to pop the video card in and fire it up and make sure it still works. Okay, so for thermal paste, I've got some Noctua NTH1. We'll give that a shot. I don't have any Arctic Silver at the moment, so we'll see how this does. This is one of my, aside from my gaming computer, my highest output CPU, so it's going to generate the most heat. So if the Noctua holds up to that, it's good for anything else. So, but we'll give it a shot, see how it goes. If anything, with this much room in the case, very easy to pop it out and clean it off and put some new paste on it. So let me get that all squared away, and then I will be back. Okay, I've made all the connections except for the 4 hard drives. So I got power plugged in and turned on, as we see by the RGB. This board has a little bit of RGB. It's a workstation board. I don't care too much about RGB, but it seems to be a thing these days. Gonna hit the power button for the first time, and we should get some fan spin and get some stuff booting up. Well, the Gigabyte turned on. Down here we can see it's trying to post. Don't have any video yet, but that's because I have my monitor set to the wrong port. Set this down to HDMI. And I'm still waiting, but the board is posting. And I have video. So, man, this board takes a while to post. And it's complaining to me that there's no keyboard, but that's fine. We don't actually have anything hooked up yet. And Windows loads. So everything is good to go there. Gonna shut down this machine, hook up a keyboard real quick just so I can turn it off. Then I will finish putting on the hard drives and everything like that. And we will then create a RAID array, which essentially is going to be turning on the computer and letting it chew for probably 6 hours or so, because doing a long format and an initialization on this RAID array, it's going to be 8 terabytes redundant. So, because it's going to be four 4 terabyte drives, so it's going to take it a while to initialize that and build that. So we'll get it shut down, and then I will pop the 4 hard drives in. We'll be good to go. Alright, I've got 1 drive in. They're 4 terabyte black editions. They go in these trays. One of the things I really like about these trays is these are actually metal. You guys can't hear that, but these are metal hard drive trays, and the drives just pop in like that, and they make a connection. So I got to get the other 2 drives in here, and then we will see if the array will build. So while I'm putting these last 2 hard drives in here, just a couple of quick thoughts about RAID in general and its use in home computers. I've migrated to most of my primary home machines if they're not purpose-built. So the multi-purpose machines, the ones I and my wife use on a regular basis, they all have RAID drives in them. I've kind of standardized on RAID 10 simply because when you work on computers long enough, hard drives just tend to materialize around you. and I had plenty of hard drives to populate them with. Gives us the redundancy that I'm looking for, but it also gives us a speed boost on the drives. My primary bulk file storage is RAID 6 as opposed to RAID 5. The reason it's RAID 6 is because it's 26 hard drives. So the odds of a single drive failure are higher than average when you have that many hard drives in a RAID set. So it's running RAID 6, but I don't need that to be super fast storage because it's not loading games, and it's not it's just there for bulk file storage for my videos and things like that. So I don't need it to be completely blazing fast. Don't want it to be pokey either, but it doesn't need to be crazy fast. Also, because it's bulk storage, I didn't want it to take the size hit on with it being RAID 10, because this is going to be a RAID 10 array, but this is 4 terabytes, 4 terabytes, 4 terabytes, and 4 terabytes, but I only end up with 8 terabytes in redundant. If I went with RAID 5, I would take a slight speed hit, but I would actually end up with 12 terabytes. So RAID 10 is the highest performance until you get into server stuff. RAID 10 is the highest performance, but you do take a size penalty, because instead of just losing the size of one drive, you're losing the size of all of the drives, or 2 of the sets. So it'll be a stripe, and then the 2 stripes will be mirrored for the redundancy. So it'll still be quick, but it won't be as big as it could be using a different RAID set. Now, these Intel boards, a couple of the traps that I've fallen into was initially because this was going to be my editing computer. I was going to try to run 6 4 terabyte drives in it. That turned out not to work. It'll do 6 drives, but the controller runs out of I/O if you add an M.2 drive. So because I have an M.2 drive for the OS, and then I have the RAID sets for my data and bulk storage, I'm maxed at 4 drives. Now, because this is 8 terabytes redundant, it's going to last me a good long time. This is 8 terabytes redundant and fast, so I'll be able to edit on it. I probably still won't be able to max out the CPU when I'm rendering, which is another reason that I didn't go with a Threadripper drive or with a Threadripper CPU, is just I hit render, and some of my videos, especially for the scope videos and things like that, they're an hour and 17 minutes. This will render out an hour and 17-minute video in about 17 minutes. So it's just a monster computer, but I don't need the Threadripper, and my drives are actually the limiting factor. The drives are running a high queue time, and the processor's sitting at 67% utilization. So that's one of the reasons for this upgrade, hopefully to be able to use a little bit more of that processor and things like that. But if I had gone to one of the higher 32-core or 64-core Threadripper CPUs, still wouldn't max the thing out. So this is plenty. This is fine. I also get the Intel Rapid Storage, which allows me to do the RAID, which is for home use. I wouldn't use it in the enterprise, but for home use, the Intel Rapid Storage is actually pretty good. I started using it back when they did the drive caching. They don't do that anymore, but the drive caching, it sped it up quite a bit. But now that they actually have support for full RAID, it's not true hardware RAID because it still steals some CPU cycles, but it's not bad for home use, and it does give you some speed increase. On a RAID 10 array with the black hard drives, I tend to realistically, not benchmarks, just realistically see about 75% the performance of an SSD. So I get 75% the speed of an SSD, a good SSD, but I get 8 terabytes, and it's redundant to a drive failure. So RAID's a wonderful thing. All my computers going forward will have it. For my home desktops that are my primary use ones, for here, there's 3 of them. Yeah, so now that I got the drive set in, I'll get that frame put back on, and then we'll fire it up and just let the RAID array build. Like I said, that's probably going to take a day. When I formatted my bulk file storage over in the rack, it was a 3-week format. It just took forever to initialize the array and then do the slow format on the drives just to check them all in and make sure they weren't going to have any problems. On that one, because there's so many drives, I am using enterprise drives. I'm not using regular drives. If you're going to set up a RAID array, don't use the mainstream drives. I've had very good luck with the black editions on Western Digital, but I would not advise RAID with, I wouldn't advise RAID on non-enterprise drives. I'm getting away with it. It seems to be stable. I haven't had too much of a problem with it. But I have had on blue drives and the non-performance drives, some drives will just fall out of the array for no reason. It'll rebuild fine, but it'll just go, yep, for right now, and falls out the array. So that's one of the main, there's some minor differences between desktop drives and enterprise drives. One of the key differences is there's some software and how the drive handles internal faults to itself. And the enterprise drives are most definitely geared for RAID more than the home drives. Now, the NAS drives, they're good for RAID, but they're not good for RAID sets more than 8 drives is what they're rated for. In the Western Digital world, those would be the red drives, but I think they max out at 8, where you shouldn't put any more than that in there. If anybody's more curious about RAID, I can do a in-depth video on RAID. That wouldn't be a problem. Just let me know in the comments below, and we can do some testing there. But I think that's it for right now. I'll put these covers back on. And I'll get this finally finished up, and then I'll just do a final thoughts on what it was like to put together a PC in this Lion Lee mid-tower. So, got the 2 fans in the bottom, pushing air in, 6 fans at the top, exhausting air out. I'll throw another fan here and another fan there. This will be exhaust, this will be in, and this computer should breathe just fine. Don't expect to have any problems on it. I wanted to just do a final cut of the computer as it was finished before I put the glass panels back on, just because of dealing with reflection and everything like that. So everything's good. We know everything works. This is my main editing computer for YouTube, and it's also my workstation computer for circuit PCB design and pretty much any workstation task. I play with VMs on this. I do CAD. It doesn't care. Whatever I throw at it, it handles it with no problem. So I got no beef on that one. A PC builder's final thoughts on this Lian Li case. I like it. I'd like it to have maybe a couple of more 3.5 bays, although 3.5 drives are going the way of the Dodo at this point. And I have some unique needs. There's plenty of room in this case, lots of space. This is a 360 mil rad, room to spare. Everything fit real nice, has plenty of room, easy to work on. This is the first computer in a while I've built where I haven't actually cut my hands to ribbons on sharp steel, so real nice case to work on. I like it. I'll see how the temperatures and stuff do, but I don't expect them to be a problem. There's plenty of room for the parts to breathe. The board being recessed, or not recessed, but pushed this way, giving you room for cabling in the back. Yeah, aside from the obnoxiously large computer cases in the full tower space, this was one of the most pleasant cases to build in that I've been in a while. So I would definitely build another computer in one of these. But yeah, I'm gonna get the glass panels put back on, and I'll get everything fired up. I got to edit this video, and this is the computer I need to do that. So thanks for stopping by the lab. Hope you guys enjoyed the rebuild of a workstation class computer. I'll have a spec sheet down in the comments if anybody's curious as to what's actually in here. Don't tell my wife what's in here. We'll just go with that. Yeah, thing's a beast. Let me get the format started, and I will catch you guys in the next video. Bye for now.